What if I told you that a rock floating quietly in the darkness of space just shattered everything scientists thought they knew about how our solar system was born? Not a small correction, not a minor tweak, but a full-blown rewrite of the story we have been telling ourselves for decades. And here's the part that makes this whole thing feel almost unreal. NASA never planned to find any of this. They were just testing their equipment. They were warming up. They were basically stretching before the real race. And somewhere in that quiet stretch, the universe cracked open and dropped a secret so strange that scientists are still trying to catch their breath. Before I take you deeper into this story, do me one small favor. If space, mystery, and jaw-dropping science make your brain light up, smash that like button, hit subscribe, and share this video with one friend who always looks up at the night sky and wonders what is really out there. That single tap helps this channel more than you can imagine, and it keeps stories like this one alive. Now let me pull you into the real thing. What NASA's Lucy spacecraft found is not just another headline. It is one of those rare moments where a machine built by human hands travels billions of miles into the black, points its cameras at something we thought was boring, and comes back with a discovery that flips the textbook upside down. To understand why this matters, you have to understand what Lucy is. Lucy is not a normal spacecraft. It is not going to one place. It is not doing one job. It launched on October 16th, 2021 from Cape Canaveral, and it carries the name of a fossil. Not just any fossil, the Lucy fossil. A 3.2 million year old skeleton dug out of the Ethiopian ground in 1974. That fossil gave humans a window into where we came from. This spacecraft was built to do the same thing for the entire solar system. That is the poetry hidden inside the mission. One Lucy told us how humans began. The other Lucy is trying to tell us how everything began. Because here is the truth about asteroids. They are not just floating rocks. They are frozen memories. They have been sitting out there, unchanged, since the moment the planets were still being pieced together from dust and fire. They remember what Earth cannot. They remember what the sun cannot. They remember the birth of the solar system in a way nothing else does. And Lucy was built to read those memories one by one. This mission is unlike anything NASA has ever attempted. 11 asteroids, 12 years, 4 billion miles. No spacecraft has ever tried to visit that many asteroids in a single trip. It is like sending one explorer to 11 different lost civilizations and asking them to come back with the truth about each one. But the real prize, the real reason this mission exists, is a group of asteroids called the Jupiter Trojans. These are two massive swarms of ancient rocks that travel with Jupiter, one group ahead of it and one group behind. It, locked in a strange gravitational dance that has kept them frozen in place for billions of years. Nobody has ever visited them. Nobody has ever seen them up close. Scientists believe they are the leftovers, the untouched crumbs from the birth of the outer solar system. Primitive, silent, full of answers. That is where Lucy is going. But along the way, it had to make a couple of stops, and those stops were never supposed to matter. That is where this story turns strange. The first stop was a tiny asteroid called Dinkinesh, and I want you to remember that name because it changed everything. Dinkinesh was not part of the original plan. It was added late. Scientists noticed that Lucy would pass close enough to get a look, so they figured, why not use it as a test? A dry run? A rehearsal? Something to practice on before the real show. Dinkinesh was chosen for one reason. It looked boring, small, unremarkable. A half-mile wide chunk of rock floating in the main asteroid belt between Mars and Jupiter. The kind of object you use to calibrate cameras. The kind of object nobody writes papers about. Nobody expected anything from it. Then on November 1st, 2023, Lucy flew past Dinkinesh at a distance of about 270 miles. The spacecraft was moving fast. The encounter was over in minutes. The team back on Earth waited for the images to arrive, expecting nothing more than proof that the cameras worked. What they saw instead made the room go quiet. Dinkinesh was not alone. Circling that tiny, forgettable rock was a moon. A small companion asteroid that nobody had ever detected from Earth. Scientists named it Selam, an Amharic word meaning peace. Dinkinesh itself means the marvelous one in the same language. Both names quietly nodded back to the original Lucy fossil found in Ethiopia. Everything about this mission is threaded together with meaning. Finding a moon around a small asteroid was already a shock. Binary asteroid systems exist, but they are not common, and finding one during a test flyby that was supposed to be routine was already something worth celebrating. But then the deeper data arrived, and the scientists looked closer, and what they saw made their jaws drop all over again. Selam was not one moon. It was two. Two separate rocks, gently pressed together, fused into a single object, orbiting Dinkinesh as one. Scientists call this a contact binary. It happens when two objects drift into each other so slowly that they do not break apart. They just stick, like two pieces of clay pressed together by the softest possible hand. And what Lucy had just found was the first ever confirmed contact binary satellite of an asteroid. A moon made of two moons, orbiting a rock that nobody thought was worth visiting. Never before in the history of human space exploration had anyone seen this. Not once. Think about what that means. We have flown past hundreds of objects. We have landed on the moon. We have visited Mars, Jupiter, Saturn, Uranus, Neptune, comets, asteroids of every size. And in all of that, nobody had ever caught a contact binary quietly orbiting another asteroid. Until Lucy, on its first practice run, on an object nobody cared about. And the story does not stop there. Because when scientists studied Dinkinesh itself more carefully, they found something even stranger. There was a long trough carved along one side of the asteroid like a giant scar. And there was a ridge wrapped around its middle, a raised belt of rock that circled the entire body. Those two features told a violent, silent story. Somewhere in the past, Dinkinesh had spun too fast. The likely cause is a slow, invisible force called the Yorp effect. Sunlight hits an asteroid unevenly, and over millions of years, it slowly speeds up its rotation, like an invisible hand giving a top, a gentle push, over and over again. Eventually, Dinkinesh spun so fast that about a quarter of its own mass ripped away. That break created the scar. Some of the debris fell back and formed the ridge. Some of it drifted into orbit. And over time, that drifting debris gathered, clumped, and eventually formed two little bodies that later fused together into Selam. An entire miniature world, born from an asteroid tearing itself apart under the pressure of sunlight. If you are still with me, and your mind is somewhere between amazed and confused, hit that like button right now because you are exactly the kind of curious person this channel was built for. And if you have not subscribed yet, this is the moment, because what comes next is even wilder. The findings were published in the journal Nature in May 2024. Scientists from the University of Maryland, the Southwest Research Institute, Johns Hopkins Applied Physics Laboratory, and NASA Goddard all contributed. And the conclusion they reached was blunt. Even the smallest, most boring-looking asteroids in our solar system can hold histories of extraordinary complexity. And Lucy had just proven it on what was supposed to be a warm-up. Then came the second flyby. And somehow, unbelievably, this one was even stranger. The next asteroid on the list was named Donald Johanson. Not a rock this time in the poetic sense, but a name given in honor of the paleoanthropologist Donald Johanson, the scientist who helped discover the original Lucy fossil in Ethiopia. Think about the beauty of that. A spacecraft named after a fossil, flying past an asteroid named after the man who found the fossil, on a mission to uncover the origins of everything. But what happened at Donald Johanson in April 2025 is something no one, not the scientists, not the mission planners, not even Donald Johanson himself could have predicted. On April 20th, 2025, on Easter, Sunday, Lucy raced past Donald Johanson at a distance of about 600 miles, moving at nearly 30,000 miles per hour. The encounter was so fast and so intense that Lucy's instruments had to shut down 40 seconds before closest approach just to protect the cameras from direct sunlight. But before they shut down, they saw. And what they saw came back to Earth over the next several days and slowly, image by image, rewrote the story of this asteroid completely. Start with the shape. Before the flyby, scientists knew from telescope observations that Donald Johanson had strong brightness variations that repeated every 10.5 days. That told them it was probably long and stretched out, spinning slowly, so they expected something lumpy, something elongated. What they got instead was one of the strangest shapes ever seen in space. Donald Johanson turned out to be a contact binary, just like Selam, two separate bodies that had drifted into each other long ago and fused into one object. But the way the two halves were connected was unlike anything scientists had ever seen. The neck between the two lobes, the narrow bridge holding the whole thing together, was shaped like two ice cream cones placed tip to tip and nested into each other. That is not me getting creative. That is literally how NASA described it in their official announcement. Two nested ice cream cones, floating in space, made of ancient rock, about 8.8 kilometers long, around 4.4 kilometers wide, nearly the length of 100 football fields end to end. Scientists calculated that this asteroid formed roughly 155 million years ago, when a much larger parent object was destroyed in a catastrophic collision. The two pieces that make up Donald Johanson today slowly drifted back toward each other under their own gravity and gently reunited. Not a crash, not a violent slam. A slow, quiet coming together. Two shattered pieces of the same broken world finding each other again in the dark. Researchers from the Southwest Research Institute described its surface as strikingly complicated. craters of different ages, textures that showed layer after layer of small impacts. A geological history written across its skin like the rings of an ancient tree. But the shape was only the first shock. The way this asteroid moved is what truly broke the science team's brains. Before the flyby, telescopes had measured Donald Johanson rotating once every 10.5 days. Slow, sure, but nothing weird. What Lucy revealed was that this 10.5-day rotation was only half the story. The asteroid was also wobbling around a completely different axis. At the same time, a separate tumbling motion that repeated every 26.5 days. Combine those two movements and you get something bizarre. Donald Johanson does not spin like a planet. It does not roll like a ball. It does not turn like a top. It tumbles through space like a football thrown by someone who had absolutely no idea what they were doing. Scientists call this a non-principal axis rotation state. In plain English, it means the asteroid is spinning in a way that is deeply unstable, deeply chaotic, and deeply unusual. Most asteroids over billions of years settle into a single, smooth spin. This one has not. It is stuck in a kind of endless physical confusion. 2 spins at once, 2 motions in 2 directions. A rotation pattern that nobody had predicted, and that current models cannot fully explain. This finding was published in the journal Science on June 18, 2026. The paper was led by Dr. Simone Marchi, the deputy principal investigator of the Lucy mission, and his team, and the paper laid out 3 major, jaw-dropping findings from Donald Johanson. First, the strange double-axis tumbling rotation. Second, the impossible ice cream cone neck geometry. And third, the one that truly silenced the room when the data came in. Evidence of ancient liquid water. Yes, water. On a rock floating in the asteroid belt between Mars and Jupiter, Lucy carries an infrared spectrometer, and when it pointed that instrument at the surface of Donald Johanson, it detected something extraordinary. Iron-rich clay minerals. Now here is why that matters. Clay does not form from dry rock. Clay is not something you find on a bone-dry world. Clay only forms when liquid water sits and reacts with rocky material over time. It is a chemical fingerprint. It is proof. And finding iron-rich clay on a small asteroid that is only about half a mile wide, formed only 155 million years ago, means that at some point in its parent body's ancient past, liquid water actually existed inside it. Not ice, not vapor. Liquid water. Sitting there, reacting, shaping the chemistry of a rock in a place where water was never supposed to survive. And I want you to sit with that for a second. Because this changes something huge. If you are enjoying this deep dive so far and your curiosity is on fire, take 1 second to drop a comment below and tell me one word. Just one word that describes how this makes you feel. Awe, chills, speechless. Whatever it is, write it down. That single comment tells the algorithm that this story deserves to reach more people who love space as much as you do. Now let me tell you why this water discovery matters more than almost anything else Lucy has found. Earth is a water world, but Earth should not be. Earth formed in the inner part of the solar system, close to the sun, where the heat was so intense that most water should have boiled away long before our planet finished forming. So how did we end up covered in oceans? How did life ever get a chance? The leading theory is that water was delivered to Earth from the outside, from asteroids and comets that carried water from the cooler outer regions of the solar system and crashed into our young planet billions of years ago. The chemistry of Earth's oceans matches, almost eerily well, the chemistry of certain water-bearing asteroids. And now Lucy has found direct evidence of water chemistry on an asteroid in the main belt. That means water-bearing material was present, active, and moving around in a region close enough to Earth's neighborhood that it could have played a role in filling our oceans. Every drop of water in your body, every glass you have ever drunk, every ocean, every river, every storm cloud, all of it may have started as ice locked inside rocks like this one. Scientists compared the clay minerals on Donald Johanson to the ones found on other asteroids. NASA's OSIRIS-REx mission visited Bennu. The Japanese Hayabusa 2 mission visited Ryugu. Both found clay minerals. But those clays were magnesium-rich, not iron-rich. That difference matters. Magnesium-rich clays suggest liquid water existed for a long time, possibly millions of years, inside a warm parent body. Iron-rich clays, like the ones on Donald Johanson, tell a different story. They point to a shorter water episode, a quick, intense chapter of liquid water chemistry inside the parent body before that parent was destroyed. And because Donald Johanson only formed about 155 million years ago, which is incredibly young compared to Bennu and Ryugu at 1 to 2 billion years old, it may represent an entirely different chapter in the history of water in the solar system. Each of these asteroids is a page. Each one holds a different piece of the same enormous story. And Lucy is quietly turning those pages, one by one. Now stop and think about what has already happened. Lucy has made only 2 flybys. 2? Both were rehearsals. Both were warm-ups. And both delivered discoveries that were, in their own categories, the very first of their kind in human history. A contact binary satellite orbiting an asteroid. A wobbling, double-lobed rock carrying the chemical fingerprint of ancient water. And these were the practice rounds. The main event has not even begun. Lucy will not reach the Jupiter Trojans until 2027. And when it does, no one truly knows what it will find. Because no spacecraft in history has ever visited a Jupiter Trojan. Scientists have models, theories, predictions. But as Lucy has already shown us twice now, models are one thing and reality is another. The Trojans are believed to be some of the most primitive objects in the entire solar system, darker than most asteroids, rich in carbon, possibly holding organic molecules older than Earth itself. Some scientists suspect they did not even form near Jupiter at all. They may have come from the outer edges of the solar system, far beyond Neptune, and been dragged inward and captured by Jupiter's gravity during a period of massive cosmic rearrangement billions of years ago. If that theory is right, then Lucy is heading toward messengers, ancient travelers from the furthest and oldest parts of our cosmic neighborhood, frozen witnesses to a chapter of the solar system that no human has ever seen. Lucy will visit at least 6 of these Trojans between 2027 and 2033. Some of them belong to the Euripides family, a cluster of asteroids believed to share a common shattered ancestor. Another target is a rare near-equal mass binary pair called Patroclus and Menoetius, 2 similarly sized rocks quietly orbiting each other in the dark, holding each other in place with nothing but gravity and time. Every target is different. Everyone carries a different chapter of the story. And after what Lucy has already discovered on its supposedly boring warm-up stops, the entire scientific community is holding its breath about what comes next. Quick pause. If your mind is buzzing with what-if questions right now, you are exactly the kind of viewer this channel was made for. Give this video a thumbs up as a small thank you for what NASA's team has poured into this mission for years, and share it with someone who thinks space is the coolest thing humans have ever done. Every share pushes real science further into the world. Dr. Hal Levison from the Southwest Research Institute in Boulder, Colorado, is the principal investigator of the entire Lucy mission. After the Donald Johanson flyby, he said something that has stuck with a lot of people in the science community. He called the warm-up asteroids, proving to be quite interesting in their own right. That may be the biggest scientific understatement of the decade. These were never meant to be interesting. They were meant to be rehearsals, practice targets, simple tests. And yet both of them deliver discoveries that will be quoted in scientific papers for the rest of the century. There is something even deeper hidden inside this story. Something that goes beyond the numbers, beyond the rocks, beyond the missions. We are living in the greatest age of space exploration humanity has ever seen. Our spacecraft are smaller and smarter. Our instruments are sharper. Our computers process more data in a single second than the entire Apollo program did in a lifetime. And still, again and again, when we go somewhere and look closely, the universe surprises us, not gently, not politely, fundamentally. Rocks we thought were boring turn out to hold ancient miniature solar systems. Asteroids we thought were simple turn out to be tumbling in impossible ways. Places we thought were dry turn out to have once held water. Every single time we point a lens at something new, the answer is stranger than the question we walked in with. What Lucy found at Dinkinesh should not exist. A moon made of 2 moons, born from an asteroid slowly ripping itself apart under the touch of sunlight. What Lucy found at Donald Johanson should not behave the way it does. A peanut-shaped, ice cream cone-necked, double-axis, wobbling rock carrying the fingerprint of ancient water formed only 155 million years ago in a belt of debris between 2 planets. And both of these were the practice runs, the rehearsals, the tests. The real destinations are still ahead. This is exactly why missions like Lucy matter. This is why humanity spends billions of dollars to hurl a spacecraft on a 12-year, 4-billion-mile journey through the darkness. Not because we know what we will find, but precisely because we do not. Every time we look, the universe hands us a piece of a puzzle we did not know existed. Lucy is out there right now. It is moving through the main asteroid belt at more than 30,000 miles per hour. It is heading straight toward Jupiter's gravitational neighborhood. It is carrying instruments that have already been sharpened and calibrated by everything it has learned so far. Every day, engineers at the Southwest Research Institute, NASA Goddard, Johns Hopkins Applied Physics Laboratory, and Lockheed Martin are tracking every heartbeat of that spacecraft. Every data point is another sentence in the biography of the solar system. Every image is a page from a book that no human has ever read before. Here is what we know. The solar system formed about 4.6 billion years ago from a swirling cloud of gas and dust. We know it went through periods of chaos, giant planet migrations, colossal collisions, slow settling. Eventually, it became the calm, familiar arrangement we see in the night sky today. But we do not know the details. We do not know exactly where different materials formed. We do not know exactly how water moved through the system. We do not know exactly how the building blocks of Earth were pieced together. Lucy is out there searching for those answers, and the only witnesses that survived, the asteroids, the silent watchers, the frozen fossils of the earliest solar system. They saw it all happen from a front row seat. And they have been holding their secrets ever since. Until now. Because a half-mile wide rock, drifting quietly in the middle of the asteroid belt, just whispered to us that liquid water once lived inside it. And that should not be possible. It is too small. It is too young. It sits in the wrong part of the solar system for water to survive. And yet, the chemistry is there, locked inside iron-rich clay, written into the surface. Undeniable. That is the kind of discovery that reshapes textbooks. That is the kind of discovery that forces scientists to question their assumptions and rebuild their models from the ground up. That is what great science actually looks like. Not confirmation of what we already thought, but a door swinging open onto something we never expected to see. And Lucy is still moving. The Trojans are still waiting. Whatever is out there, it has never been seen by human eyes. Not once. Not in any generation before ours. Think about that. For 4.6 billion years, those objects have been sitting in the cold, in the dark, in the deep silence at the edge of Jupiter's orbit, waiting. And in just a few years, a small spacecraft named after a fossil is going to arrive and finally look them in the face. If Lucy's warm-up flybys already stopped the world with their discoveries, what happens when it reaches the real targets? What happens when we finally see what has been hiding in the Trojan swarms all this time? Some scientists believe we may find organic molecules older than Earth. Others think we may find clues about how life's ingredients were scattered across the young solar system. A few even wonder if we might find hints of processes we have never imagined. Whatever the answer is, it will not be small. Because Lucy has already proven one truth over and over. The universe does not do small answers, it only does big ones. And every time we dare to look closer, it dares us to think bigger. So the next time you step outside at night and look up at the sky, remember this. Somewhere out there, past the moon, past Mars, past the asteroid belt, past the giant clouds of Jupiter, a small spacecraft is quietly speeding through the dark. It carries the name of an ancient fossil. It carries the hopes of thousands of scientists. It carries the curiosity of an entire species. And it is heading toward a place no human machine has ever been. In 2027, Lucy will finally arrive at the first of the Jupiter Trojans. And if history is any guide, whatever it finds there will not just surprise us. It will change us. Because that is what real discovery does. It does not just add facts to a book. It cracks the book open and rewrites the first page. So stay curious. Keep looking up. Keep asking questions no one has answered yet. Because the universe is stranger, deeper, and more beautiful than any of us can imagine. And right now, in this very moment, NASA is driving straight into the heart of that strangeness. And when Lucy speaks again, the whole world will listen. Because a rock the size of half a mile has already stopped the world once, and something tells me it is only the beginning.